Good morning, everyone. My name is Kathy Sobolski, and it is my pleasure to be hosting our meeting today. I'm so glad you could join us to celebrate May 2020 graduates. Due to COVID-19, we are not able to have our MAE graduation lunch in the Engineering Science Building, where you typically meet faculty into our classrooms and labs. So in its place, we brought you a virtual graduation celebration. This presentation will start with a message from the chair, Dr. Jackie Pruch. Then we will cover enrollment statistics, faculty recognitions, as well as new research projects in the department. Next, the fun part, MAE courses, clubs, and projects. Here we will try to make up for the fact that you are not able to see student projects and labs in person. This portion of the presentation will include videos and images from different capstone courses and student competitions. And finally, we will close down with a short message from Dr. Pruch. Okay, so we're ready to start. Let me just unshare my screen. And please help me welcome Dr. Pruch.
Thank you, Kathy, and thank you for putting together this great presentation. So first of all, good morning and welcome everybody, graduates and families, to this virtual celebration of the 2020 class of MAE graduates. You have worked hard to reach this major milestone in your lives, and today is the time to rejoice in your success. People often say that success breeds success, but in engineering education, only hard work breeds success. Unlike the dictionary, which is the only place where, if you think about it, the word success comes before work. You are earning today highly valuable degrees that will open for you many doors towards long-lasting and rewarding professional careers. You have gradually built a solid foundation of technical knowledge and personal skills that should give you strong confidence in your ability to succeed in any endeavor that you may choose to pursue in the future. All graduates take pride in their accomplishments, but the class of 2020 should take an even greater pride for the perseverance that you have demonstrated by staying the course towards on-time graduation, despite the unexpected challenges, both of technical and academic nature, that you had to overcome following our transition almost overnight to online teaching. Even though we cannot shake your hands today, we hope to leave you with a few good memories by watching together a brief overview of highlights from student and research projects in which many of you have been engaged during your studies in our department. We will share with you a few key recent facts about the MAE department as well. So I will convey now I will pass the control to Kathy so that she can go over the presentation.
All right, thank you, Dr. Pruch. All right, let me just switch over. First, I would like to tell you about today's graduates. So today we have 9 students graduating with advanced degrees and 95 with Bachelor of Science. We're graduating 9 aerospace engineers, 60 mechanical engineers, and 26 with dual degrees in aerospace and mechanical engineering. I would also like to highlight the fact that MAE has 9 graduates from the Honors College. MAE strives to support their students through their educational experiences, not only academically but also financially through numerous foundation grants and scholarships. Annually, MAE awards over 100 different monetary grants. As you can see from the graph, the number of higher value grants is creeping up with every year. On the right, we have recent enrollment trend in the department. We are the largest department in Stettler College with over 22% of undergraduate students and staggering 24% of all PhD students. Top graph shows number of sophomores, juniors, and seniors in the last couple of years, and the bottom shows the number of master and PhD students, as well as number of female, minority, and foreign students. Next, we will have Dr. Machino tell us about the international programs available in MAE.
The MAE department is a leader in international programs. We have two of the most outstanding study abroad programs at West Virginia University. One is the Industrial Outreach Program in Mexico, in which West Virginia University students team up with Mexican students to solve engineering problems in industry. They can earn 9 credits and enjoy the wonderful cultural activities in Mexico. The other program we have is the spring semester at the University of Rome Tor Vergata. In this program, students can earn up to 18 credits towards their degree and enjoy the magnificent cultural opportunities that Rome and Italy have to offer.
And now a little bit about our faculty. This information shows you some of the data we keep track of to assess the department's productivity and effectiveness in teaching and research. Since the 2020 statistics are not yet available, let's take a quick look at the 2019 and 2018 data. In 2019, MAE faculty taught over 200 class sections consisting over 7,000 students. The average SEI score is above 4 out of 5 for all categories. In research, MAE has shown nearly 10 million in expenditures and published over 100 journal papers. In August, we will welcome new faculty member, Dr. Nicholas Szczeciński. Dr. Szczeciński will join our department as a tenure-track assistant professor with focus on robotics. Finally, I want to show you the current faculty breakdown with 3 new teaching assistant professors, 5 assistant professors, 12 associate, and 14 full professors. This past year, we had 2 faculty members recognized for their professional contributions. Dr. Browning has received a letter of recognition for significant scientific and engineering achievements from the U.S. Naval Surface Warfare Center. Dr. Browning's research focuses on unmanned aerial systems and experimental aerodynamics, aerostructural design with emphasis on micro-aerial vehicles. Dr. Thompson was named Fellow of the National Academy of Inventors. This program highlights academic inventors who have demonstrated a spirit of innovation in creating or facilitating outstanding innovations that have made tangible impact on quality of life, economic development, and the welfare of society. This year, 4 of the MAE faculty members were recognized by the Stettler College. Dr. Eckerman received Outstanding Researcher and Educator Award. Dr. Dumitrescu received Outstanding Researcher and Advisor Award. Dr. Souveneri was recognized for student advising by Stettler College, as well as the university with the Nick Evans Award for advising. And finally, Dr. Johnson was also recognized an Outstanding Educator of the Year. In research news, Dr. Mehta was awarded a grant from National Science Foundation to research more accurate ways to predict space weather using artificial intelligence and machine learning. Dr. Song also received a grant from NSF. Dr. Song's group works on oxide materials for thermoelectric applications. Thermoelectric devices have an ability to convert temperature gradients into electrical power and generate electricity from waste heat. Dr. Gross was promoted to an IEEE senior member and awarded a grant from the National Geospatial Intelligence Agency to develop an approach for a team of UAV and ground robot to search an underground tunnel to assist in rescue missions. As today's graduates become alumni, I want to tell you about MAE Academy of Distinguished Alumni. ADA was founded in 1990 to honor graduates of MAE who bring honor to the discipline and who have had a distinguished professional career. To be nominated, you must wait at least 15 years. To be inducted, you must receive an affirmative vote of at least 75% of the ballots returned by the membership. Since 1990, 62 alumni were inducted, including 8 CEOs, 15 fellows of various professional societies, and 22 directors. Among ADA, we can find a director of NETL, F-22 program director, and director of the U.S. Space Shuttle program. Finally, we come to student projects, clubs, and competitions. In the next few slides, I will give you an overview of various capstone courses, and I will also highlight activities from just a few of the student activities and clubs. Before we get started, I just want to let you know that last year MAE contributed $168,000 to student projects. So first up is EcoCar. EcoCar is a capstone course geared towards EcoCar Mobility Challenge sponsored by DOE, GM, and MathWorks. In this competition, 12 teams are challenged to apply advanced propulsion systems as well as connected and automated vehicle technology to improve the energy efficiency, safety, and consumer appeal of the 2019 Chevrolet Blazer. EcoCar is a multidisciplinary program with not only mechanical and electrical engineers, but they also have their own communication director. So let's have Ms. Field tell us all about the EcoCar.
Well, I was always kind of interested in STEM when I was in high school, but I wanted to be a little bit more social, participate a little bit more in the communications world. But then I actually had an internship in purchasing for Volvo Group Trucks in Hagerstown, Maryland. So working with all of the engineers there kind of really piqued my interest and sparked my interest in wanting to work more in the STEM field for communication. Well, with EcoCar, as the communications manager, I am in charge of the social media for all of the WVU EcoCar team. And so learning a lot of the direct and digital media that I learn in my IMC courses kind of helps me figure out new ways to engage our audience and get new followers, as well as just kind of gaining a little bit more experience with traditional writing. I have to write press releases and media advisories, and I'm learning a little bit more of how to do that in the best way possible. Get involved in any way you can, and don't necessarily just look within the media college. Because even with EcoCar, we have students who are interested in working with communications who are from the Reed College of Media. So look across campus. There are other clubs out there who may not be necessarily media, but are still needing people to be in charge of communications.
The West Virginia University EcoCar team is collaborating with the Statler College of Engineering and Mineral Resources as they plan to compete in the Eco College Mobility Challenge. The challenge is a 4-year automotive competition that provides hands-on experience in designing and building next-generation solutions. This year, WVU's team revealed the 2018 Chevrolet Blazer to be the car of choice.
For this competition, there's 12 different teams in North America. 2 teams are from Canada. And at the end of each year, there's a final competition where each of the teams have to do a presentation. And then now that we have the Blazer, there's also going to be dynamic testing as well with some of the components they're going to be putting into the Blazer.
Last year, WVU placed second in the competition, with Ohio State coming in first place.
Okay, Baja is another capstone course aimed at the SAE Collegiate Design Series competition. In this competition, the students design, engineer, build, test, and compete with a single-seat, all-terrain sporting vehicle. The objective is to produce a prototype vehicle for recreational market with a superior performance over rough terrain and off-road conditions. In the past, our Baja team have won competitions 4 times and placed in top 10 on numerous occasions. And now let's hear from the Baja team. Next, we have Formula. Formula is also a capstone course aimed at competing at the International SAE Race Car Competition Series. The Formula team is challenged to design and construct a single-seat open-wheel race car targeted for non-professional weekend autocross racers. Formula program gives students an opportunity to enhance their professional development by applying classroom-learned concepts using the latest design and fabrication tools. One of the tools used by the team was MAE Wind Tunnel, and here is the video. And now we have Design Build Fly. Design Build Fly is a technical elective course focused on providing students with the knowledge of the fundamentals of unmanned aerial vehicle design, construction, and operation. For the past 20 years, DBF teams have been competing at the annual AIAA Cessna Raytheon Missile Systems Student Design Build Fly competition. The competition's mission this year was a banner towing bush plane, and the students designed and built monoplane and a biplane to fulfill this mission. Yet again, the competition was canceled, but the team has shared with us some of their test flight videos. I have to warn you, the students were recording these videos were very excited, so here it is.
Ready?
Yeah.
Watch out.
Whoa! Whoa! Holy crap! Okay.
Holy shit.
Whoa!
Ready, Captain? Oh, look at that turn. How controllable is it? Like, it's a lot. It's easy to fly. Like, are you gonna be able? You're in control right now. Holy fuck. It's designed to have 26 pounds in it. So that makes sense. Yeah.
Yeah, you're looking at 2 minutes now. Well, just over.
Holy shit.
Oh.
So she's going. There's a loop. There you go. Ooh. It's the only way I can do it.
Beautiful.
I gotta loop it down. If it was. We lost something.
Uh-oh.
One of the arms is stuck out.
Uh-oh. Oh, sick! Yes!
Easy.
Woo! Easy. Beautiful.
I can't believe that. That was like.
That just took right off. Oh my god.
Remarkable. Good job, boys.
We just gotta make sure it does that fully loaded. Can do anything.
Wait, it doesn't have to take off with passengers in 20 feet?
Oh, true, you're right. Well, with the banner then.
I already see you landing in 20 feet.
Hella.
Do it!
Oh my god, no, don't do that! Oh, woo! Oh my god, Justin!
Justin, stop doing it too much.
Here.
Fly over rocketry, that's all.
Yeah, show off a little flex. Whoa, hello. Whoa, okay.
We lost that. Oh no! That was Susan West.
Yeah,
Debbie is glad to be home right now.
Debbie's not even close to. Debbie can't be jealous because Debbie's basically just like dead.
Debbie is dead to us.
Oh!
So now we have Human Power Vehicle. HPV is another capstone course. Students in HPV focus on designing and building the next generation of man-powered transport machines. The objective is to design a competitive vehicle that will excel in a drag and endurance race, and then build, assemble, and travel to compete against other universities. The bike is designed with consideration for safety, portability, aerodynamics, ergonomics, and speed. And here's Connor McCormick telling us all about it.
Hi, my name is Connor McCormick, and I'm the team captain of the West Virginia University Human Powered Vehicle team. And this is our design presentation covering all of our team's progress since the submission of our design report in February. This year's vehicle featured a modular design which made use of carbon fiber tubing and nylon lugs. As you can see to the left, there are multiple nylon lugs for the different components. These were all 3D printed using an Ultimaker 2 Plus owned by the university. This allowed for rapid prototyping and different design iterations to ensure each lug fit properly. This modular design allows us to be able to swap out any lug for a new lug which could fit different components such as a bottom bracket, headset, seat post, etc. The vehicle was manufactured by bonding the tubes and lugs together using a strong adhesive epoxy. To the left, you can see a picture of the seat tube being bonded to the bottom bracket lug. We started with the front diamond, as you can see in the picture on the right, and then we moved to the rear diamond. Once this was done, we mounted the shells inside of the head tube and bottom bracket, and then the vehicle was complete. After bonding, we then used a filler epoxy, which was used to manufacture carbon fiber, fiberglass, etc., and then that provided the vehicle with extra stiffness. The air device was constructed using polystyrene foam, and foam components were cut and then bonded using epoxy. Sanding was done to ensure smooth edges and rounded corners, and epoxy was used to fill any gaps to ensure that there was no vortex generation. The air device also featured an 8.5 by 11.5 by 13.5 inch cargo space with a pin latch for the parcel. The air device was to be painted, however, we did not paint it because we realized that the paint ate away at the foam. The end result was a product which was dimensionally accurate and very well aligned. The total weight of the vehicle was 20 pounds, and this does not include the fairing. This includes all components that you see to the right. We expected the vehicle to be about 15 pounds in our design report, including the fairing. However, we think that this 5-pound difference in weight is mainly due to the generous application of epoxy and our inability to accurately estimate the weight of all components that we put on the vehicle. We didn't have enough time to post-process the frame, and so most lugs, as you can see, still have epoxy lurking, and we need to sand that down and paint the frame. Cables were also not internally routed as we had planned, since we had a time constraint and assembled the bike within about 4 days. This is a video of me riding the bike. This is the first test ride of the vehicle. I'm able to shift through all gears, and the vehicle was able to be handled at low speeds as seen. I'm able to corner the vehicle here, and then I begin accelerating. The video does not show it, but at the end of the road I am able to brake in a very short distance. I eventually took the vehicle for a test ride, and I was able to ride it about 5 miles in the time that I had. After a test ride, I would say that the vehicle's ride quality was excellent and would definitely compare it to that of a commercial off-the-shelf road bike. The handling was as designed. We designed the vehicle to have a mid-range trail for stability at high speeds and forward centers of gravity, but then also the ability to corner at low speeds. I would say I experienced both and was happy. The vehicle was mechanically reliable, and I was able to use all gears, and the brakes were excellent. The frame was structurally sound, and during my test ride I made sure to go over speed bumps, potholes, etc. to see how the vehicle would stand up. I don't know how the vehicle will handle wear and tear, however I can say that the vehicle was fast and I do think it would have done well in competition. However, I can also not comment on the vehicle's fit to other riders since it was designed to fit riders of multiple sizes. I am the mid-range rider that we did design for though, and I will say that I did feel comfortable in the vehicle. Unfortunately, due to time constraints, the team was unable to test the vehicle after construction. Our plan was to conduct some speed testing on the vehicle and then do some short distance and long distance endurance testing and compare that to data that was put into our design report. We also wanted to compare the vehicle to a commercial vehicle that the team owns. You can see a test matrix on the right, and you can also see different rider positions below. We wanted to do testing with all of these positions so that we can ensure that the vehicle fits as designed. In the future, the team would like to look more into the modular design featured on this vehicle. We'd like to look into different lug materials, frame materials, and bonding methods. We know that weight reduction is extremely important, especially with the vehicle being overweight. The nylon lugs were heavy, and we think that this weight could be reduced by doing more research into the material properties of nylon. We also think that less epoxy could have been used, however, we are unsure. We also would like to research the possibility of non-permanent modular assemblies so that vehicles can be disassembled and reassembled using different lugs for different components. This would mean a truly modular vehicle, and we think this could have significant impacts on the market. The human-machine interface was also very important on this vehicle, and we'd like to continue collecting data so we can understand more about it. The vehicle featured geometries which accommodated multiple sizes of riders, and we think this is very important to explore and could have a significant impact on future bike designs.
All right, on to robotics. Robotics, just like EcoCart, is a multidisciplinary group with core researchers mostly from Lane and MAE departments. Robotics team has probably produced the most of the recent competition wins, which are scrolling on the right side. The main highlights happened in 2014 when the WVU robotics team won first place in 4 different competitions, and in 2016 they took top prize at the NASA Sample Return Robot Final Challenge. As you can imagine, the robotics capstone course is very popular among our students. The course targets the University Rover Challenge conducted by the Mars Society. Next, I'm going to show you 2 videos. First video will show overall activities of robotics research group, and the second, specific developments in the capstone course.
Working on robotics at WVU, it's honestly a great experience. Everyone wants you to be involved. That's something that we have that's pretty special here.
I fell in love with robotics. I fell in love with the camaraderie. I fell in love with the people. We are very much a family here.
The students are in charge of managing everything and creating everything. It's as close to real life as you can get.
I really enjoy the problem, like the complicated electromechanical programming problem.
It's exciting being able to see that the stuff I learned in the classroom and working on projects I can use and apply to save lives or change the way that people live.
Agriculture to healthcare to intelligent transportation system to manufacturing, projects that can benefit human life and have an impact to humanity.
Robotics is a really fun and captivating discipline. We collaborate with everybody from NASA's Jet Propulsion Lab to entomologists here at WVU to people that are experts in computer vision, navigation, autonomy. You actually get to go out and realize what you're working on for your research in the field.
My favorite part is just being in a very open, collaborative space where everyone is supportive. Being a female engineer, it's very, very hard in a very male-dominated field to be taken seriously or listened to. I never once felt that with them.
There's a pretty strong support system here from the professors.
I've never had an issue approaching a faculty and saying, I want to get involved with this project.
We like to have physics students come here, and we like to have geology students come here. We like to have arts students in business management and all variety of research disciplines. Everybody has their own unique strengths. They will together do great things.
Creating a diverse team full of different majors.
You have to make that initial step, but once you're in, then that's really all you have to do. My favorite part about robots in particular is that it's a combination of a lot of different fields.
There's a bunch of different resources in this lab, but the greatest thing was you're touching the project. They're not getting busy work. That's huge.
Humans, we learn from our mistakes. Everyone is willing to put in hard work and effort for a bigger purpose.
It's such a new field that you get to experiment with different things all the time. If you don't test something until it breaks, chances are you're not going to be as ready as if you let it fail whenever you have time to let it fail and then improve upon it for later.
We have a lot of work that we're doing with NASA on Mars rover autonomy, and we're developing a robotic pollinator. And also we're looking at navigation of both drones and robots in subterranean environments.
WVU has a really successful record of winning robotics competitions.
My dream job is definitely to work with robotics.
I've learned about overall systems integration from all of these projects, and I've also learned how to work inside of a team on these things. Because obviously I wouldn't be able to do those dream jobs by myself. So
You're probably going to want it more after you get here, if I'm being honest. You're probably going to get here and be like, oh, now I want to do these things or that.
Don't be scared, just do it. Make that leap of faith.
انت مكان مره قاعد يطلع صوت فوق.
كان صوتك بعد يا احمد. اي والله.
Hi, my name is Connor Cass. I'm with the West Virginia University of Robotics.
This is my son.
We'd like to introduce our robot Thor to the Innovation Rover Challenge.
قلت لي بطل السماعه.
The Mountaineer Drivetrain Sub-Team's objective was to provide a stable platform to carry all task-related payloads during the URC competition. Prevention of deflection and vibration while maintaining traction and mobility were the main challenges while addressing the objectives. The drivetrain was designed with a streamlined system containing a differential bogie, a reinforced chassis, and an integral wheel hub design. The wheel hubs featured 3D printed components to reduce weight while allowing for transference of torque. The wheels themselves are polyurethane with treads designed to enhance traction.
The Mountaineer Manipulator subteam has been focused on developing an effective manipulator capable of achieving all objectives set in both the extreme retrieval and equipment servicing missions. To complete such tasks, the design requirements such as structural rigidity, load capabilities, and manipulative dexterity were accounted for to develop a competitive, mission-ready manipulator. Utilizing 6 degrees of freedom and inverse kinematics, the Mountaineer Manipulator has the ability to complete tasks in an accurate fashion, meanwhile enabling the user to have ample control over the manipulator's position. This includes utilizing 3 linear servos and 4 dynamixel servos for an end effector that has flexible positioning capabilities. In addition, a custom base plate and track design was designed to improve structural rigidity.
The Mountaineer Electronics Subteam provides the necessary infrastructure for programming and communications of the rover system. Since commercial electronic devices require different voltage levels and current limits, The system requires a power distribution architecture capable of converting the battery voltage to the necessary voltages of those devices.
The communications subteam works on transmission of data from the base station to the rover. The system is a 2.4 gigahertz line that is powered by Ubiquiti M2 rockets. On the base station side, we use a 90-degree sector antenna. On the rover, we have an omnidirectional antenna. We have done reliability testing on the system, and we have found that the system works up to 1.5 miles and has a maximum throughput of 87 megabits per second.
For the autonomous traversal task, the Mountaineer Programming Subteam has developed capabilities to navigate GPS waypoints, search for tennis balls, and avoid obstacles and untraversable terrain. To facilitate waypoint navigation, a GPS-based path planner will generate a waypoint at the given tennis ball coordinate. Along the way to the waypoint, if any obstacles are detected in the path of the rover will enter the hazard avoidance state.
Tennis ball detection is performed using a TensorFlow approach, as well as a basic object detection algorithm. The OpenCV-based object recognition algorithm can quickly detect the tennis ball based on shape and color under ideal conditions. The strength of the TensorFlow approach is the ability to train the neural net to detect the tennis ball under a wide variety of conditions.
The Mountaineer Science Subteam led efforts to determine the most effective method of identifying potential cache locations while abiding by the no-spill policy. A tiller agitates the ground to collect subsurface soil and bring onboard sensors into contact with the sample. Brief vectors of electrical conductivity, moisture content, pH levels, and temperature are recorded for each soil sample. Some sites may be sampled several times to further support the signs of life in the area.
All right, on to microgravity. Microgravity is a CEGER project course where students conceive, propose, design, build, and test a microgravity experimental payload. The projects are sponsored by NASA. The students conduct their experiments under conditions of reduced gravity aboard NASA microgravity research aircraft, which allows for 20 to 24 seconds intervals of reduced gravity. This year's project was titled 3D Printing of Titanium Oxide Foams in Microgravity. And I have some images from the last flight in November 2019. As you can see, the first image shows an experimental payload. It must be fully enclosed and automated as much as possible, since you want to control which parts of the experiment move and react during the microgravity interval. There are tons of work and preparation conducted before these flights, but it does look like they're having a blast. Next, we have WVU Experimental Rocketry Club, which is a student organization focused on competing at the Spaceport America Cup. The Cup is an intercollegiate rocket engineering competition. At the competition, the students launch solid, liquid, and hybrid rockets to target altitudes of 10,000 and 3,000 feet while carrying a minimum of 8.8 pounds of payload. Last summer, WVU Rocketry Club has taken second place in the 10,000 feet category. Although they can be a bit silly, they spend all year on planning, design, fabrication, and testing for the next year competition. Yet again, COVID-19 has canceled this year's competition, but the Mountain Mama is ready to fly. Finally, the pumpkin drop. Every October for the last 32 years, Pumpkin Drop has brought numerous middle school, high school, and collegiate teams to the Engineering Science Building. The goal of the competition is to develop a contraption which will allow a pumpkin to survive an 11-story fall and land close to a target mark on the ground. The variety in designs is countless. The competition is hosted and overseen by MAE staff and members of the local student chapter of the American Society of Mechanical Engineers. They are the ones who make this event run smoothly, even with the hundreds of middle schoolers running amok. The money raised during Pumpkin Drop is donated to the Ronald McDonald House. Now I have two videos. One shows a pumpkin that did not fare very well, and the second is a survivor. Here's the first one. And now let me show you the second one. That's beautiful. Yep, that one made it. Before I hand over the screen back to Dr. Pruch, there's just one more thing. We would like to take a moment to honor Mr. Dave Sully on his very recent retirement. Dave, thank you for joining us today on your very first day of this new chapter in your life. Mr. Sully has been an advisor and mentor to our undergraduate students, and because of your dedication, understanding, and patience, our students are fulfilling their dreams. We truly appreciate everything that you have done for MAE. We honor you today and wish you the best in all that you do. We're really going to miss working with you. Congratulations, Dave. Enjoy your newfound freedom and make the most of it. Happy retirement. And this brings us to the end of the 2020 MAE Virtual Graduation Celebration. At this point, I would like to thank everyone that has helped to put this presentation together. This was definitely a group effort, and I could not do it without them. Thank you, guys. Finally, I would like to hand over the screen to Dr. Pruch for closing remarks. Just give me a second. I'm going to unshare my screen. All right, Dr. Pruch.
This was very uplifting and well done presentation. Hopefully our graduates enjoyed seeing some moments from their educational experience in our department. In addition to Dave, that will be very much missed, but he sure deserves a happy retirement. I would like to acknowledge also Pat Goldie, who served as our office administrator for many, many years, and she has retired in February, but fortunately she's still working part-time during this transition period. And I'm sure that many of our graduates have interacted with her during their tenure in our department. So anyway, we hope that you have enjoyed our presentation as a friendly send-off and a good warm-up for the official commencement. It's just about to start at 11 o'clock. As you are closing one chapter in your professional growth, each of you will embark on new adventures and will encounter new challenges, but you are now well equipped in your journeys to greatness. No matter how burnt out some of you may feel right now from learning difficult subjects, please remember that learning never stops, and it will continue to be the secret to all your future successes. You have earned a WVU, not just your diplomas, but also a well-rounded and solid education that should lead you toward fulfilling careers for yourself and prosperous lives for your families. We wish you well and only the best in everything you do. Please stay in touch with us, come back and visit us, and always remain loyal mountaineers.
Okay, thank you very much. So thank you everybody for joining us. I'm going to switch over to my screen back, and you will see our names of our graduates scrolling through as we say goodbye. Thank you, everybody.
Goodbye, everybody.